Okay, on to lesson 6.5 for Algebra 1. If you guys notice, these notes are a little bit different than I normally do them. These are just a bunch of examples, which it's kind of easier than doing the PowerPoints. There's a fun little cartoon you all can read at the beginning. It makes me laugh, so go ahead and read that when you want. But let's get started. So in this section, we're going to look at graphing linear inequalities. But I want to start by reviewing how to just graph regular equations, because you guys still struggle with that sometimes. So there's two ways you could graph. You can either find the slope and the y-intercept and plot those, or you can find the x and y-intercepts. That's when, you have 0, comma, whatever the y-intercept is, and x-intercept, comma, 0. And so we would plot those and then connect those. So let's try the first one. Well, the first one's already in y equals mx plus b. So that means that the slope is -2, or you could put it over 1, and the y-intercept is 3. So to plot this, I'm going to go up to 3. I'm going to use the 2 as my rise. I'm going to go down 2 because it's negative, and to the right 1. So I could connect those. And that's how I'd graph that one. Let's try doing the intercepts on the next one to graph. So I'm going to do the y-intercept first. So I'm going to plug 0 in for x. So I get negative y equals 6. So my intercept is -6. So that's the point 0, -6. For my x-intercept, I plug 0 in for y. So I just get 2x equals 6. So x is 3. So that's the point 3, 0. So if I plot those for 3, 0, I'd go over 3 and up 0. And for 0, -6, I'd go over 0 and down -6. 1, 2, 3, 4. I should have drawn more down here at 6. So now I just connect those. So there's the two ways we can graph. Let's do the last one. I'm actually going to do this one with slope intercept. So in order to do that, we need to get it into y equals first, okay? So I'm going to move the 6 over because I want to keep the y positive and then divide by 3. So I get 1/3 x minus 2 equals y. And if you notice, I can just flip that, and I have y equals mx plus b. So I'm going to go down to my intercept at -2, and then my rise is up 1 over 3. So there's how I graph that. So you guys really need to know how to graph, okay, to do this next unit. Now we're going to look at graphing inequalities. So that was graphing equations. We're going to look at graphing inequalities. Well, here's the step for graphing inequalities, okay? Step 1, you always want to graph the boundary equation first. What that means is it's the inequality, you would graph it by replacing the inequality sign with an equal sign. And remember, you may need to solve for y first to make it look like y equals mx plus b. Once we graph it, we're going to, we have it in the way we want. We're going to graph it using either a solid line or a dashed line. A solid line is used for the greater than or less than or equal to signs. Dashed is when we don't have the equal sign below. And then lastly, we have to decide what part of it to shade. And I'm going to show you what this means, okay? So let's try one. So we can either graph the intercepts or put it in point slope form. I'm going to put it in point slope form first. I'm going to move the 3x over and then divide by -1. Now here's the trick. When we divide by -1, anytime I divide by a negative number, I need to flip the sign on an inequality, okay? So I flipped the sign. So I have it kind of looking like a y equals mx plus b. So I'm going to make it look like that, y equals 3x minus 3. So I'm going to put an intercept down at -3 and then up 3 over 1, okay? Because it's a rise of 3 over 1. Now, what type of line should we use? Well, it's got a greater than or equal than sign, so we're going to use a solid line to graph it. so I'm going to do a regular solid line. I should have like a ruler or something to make this better. Okay, last step. You need to shade one of the sides of the line because with inequalities, it's saying that y is greater than the line 3x minus 3. So it's all the values greater than 3x minus 3. Sometimes it's hard to figure out what side that is, so I like to pick a test point. So I always pick something really easy, and if you notice, 0, 0 is a point I could pick. It's on this side. So I'm going to plug that in to here. I'm going to try 0, 0. I'm going to plug 0 in for y and 0 in for x. So I get 0 is greater than negative 3. Now, if that is true, if what you get at the end is true, you shade the side that had the point you picked. If it's not true, you shade the opposite side. So since this 0 is actually greater than negative 3, that's true. So 0, 0 is in 0, 0 is on the shaded side. So I am going to shade this whole side. So that means the answers are all the stuff on the line or to the left of it. Those are all the solutions because it's an inequality. It's not an equation. All right, let's try another one. If you guys would like, you could pause it and try it yourself. So first we need to graph it, but it needs to look like a y equals mx plus b. So I'm going to move the 2x over by adding 2x to both sides. Okay, so my intercept is down at negative 2. I'm going to go up 2 over 1. Now, if you notice, I need to use a dashed line this time. So I'm going to use a dashed line because it doesn't have the equal end. Now I need to pick a point to try. So this is just a reminder, that's the dashed line. Now I'm going to pick a point. Again, I like to pick 0, 0 because it's just so easy to plug in. So let's try 0, 0. So I'm going to put 0, 0 into this inequality. So 0. So I get 0 is less than negative 2. Is that true? Is 0 less than negative 2? No, it's not true. So 0, 0 is not on the side we shade. So that means we shade the other side that doesn't have 0, 0 because 0, 0 is on the other side. Okay? All right. So that's how you graph them if you're given an inequality. Now, what if I give you a graph and you have to come up with the equation? So let's work on that. Well, let's first decide, what's the intercept and what's the slope? Well, the intercept is where it crosses the y-axis. So it crosses down here at negative 3. The slope, so I like to go to the next point. Where does it hit the next perfect little point? Well, it hits right here and right here. So it's going up 2 and over 1 to the left. So that means it's going up 2, but over 1 negative. So my slope is negative 2. Okay. Now, is it a solid line or a dashed line? It's a solid line. So that means I'm going to have this or this in my equation. Now, we're going to use y equals mx plus b, but with the inequality sign instead of the equal sign. So we know that y, I don't want to use an equal then, because I just said we're going to use an inequality. Okay, y, and then we have the mx, so we have the slope, negative 2x minus 3. Now, which way should the inequality face? Well, the shading is above, so it's above the line. So that means that it's everything, the y values are everything greater than the line. So it faces this way because it's above the line. Okay. That's a little tricky, I know, but it's technically up here above the line, even though it looks like it's to the right, it's above. So y, all the values are above the line. Let's try this next one. Or again, you can pause and try it. That'd be awesome. Okay, intercept. It's hitting the y-axis at 0. So from here to the next perfect point, it's right here, every 1. So it's up 1 over 1, up 1 over 1. But it's up 1 and over -1, so our slope is -1. Dashed line, whoops, sorry. The dashed line means that I'm going to either have this or this. It's shaded below, so that means it's less than. So y is less than the m, which is -1x, plus b, which is 0. So we can just write this simply, y is less than -x or -1x. So here's your equation. Okay? All right, one last problem. All right, got a word problem. I know, you're fun, your favorite thing to do. All right, Ada has at most 285 beads to make jewelry. So at most, that's a really important word there. That means that she can't have any more than 285. The most she can have is 285. Okay, that's the most amount of beads. A necklace, if she wants to make a necklace, it uses 40 beads. And if she wants to make a bracelet, it uses 15 beads. We need to come up with an inequality to describe the situation and then graph it and then give any kind of combination of bracelets and necklaces that she can make. All right, well, we need variables. Let's use N for necklaces and B for beads. Now, just because we know our X and Y axes, I'm going to say that N are like my X and B is like my Y. Okay? So part A says to write a linear inequality. Well, for every necklace, it uses 40 beads. So 40N, and for every bracelet, it uses 15 beads plus 15B has to be less, the number of total beads I use has to be, I can't use more than 285. So it has to be less than or equal to. If you want to rewrite this with X's and Y's, just because that might make life easier, you guys can, that's fine. You just have to know that your beads are on the y-axis, so your number of beads for, or B are for the, what did I say, beads? Yeah, the number of beads are for the bracelet. That's what I meant to say up here. It should be bracelet. Sorry about that. You have to know these are the beads in bracelets. So this is my bracelets. These are my beads. Oh my goodness, necklaces. Because I'm calling that my X. All right, now part B says to graph it. Well, in order to graph, we need to make it look like a y equals mx plus b. So I'm going to move that over so I get 15y is less than or equal to -40x plus 285. And then I'm going to divide by 15. So y is less than or equal to -8/3 x plus 19. All right, here comes the fun part, graphing it. So we need a solid line, okay, because of that. So I'm going to go by ones. I'm going to go by ones on my, let me erase this to make this look nicer. And I'll go back and redo it. I'm going to go by ones on my x-axis just because for counting purposes. So every unit is a 1. And I'm going to go by 5s on my y-axis because I know that my intercept is 19. So that's all the way up here. I know my slope is negative 8 over 3. So I'm going to go down 8, which would put me at 11, and over 3. That's a little tricky, I know. You just kind of got to do your best to estimate. And then I'm going to use a solid line. Okay. Now, I actually know that I'm not going to have anything over in the negatives because we can't have negative bracelets and necklaces. Necklaces, bracelets. So we know that it's y is everything less than the line, meaning it's everything below it. If you wanted to plug in a point, you could. I'm only shading the positive stuff because in a word problem, like I said, we're not going to have negative bracelets and necklaces. So part C says choose any ordered pair in the shaded region, okay, because that would give us the combinations we can have. So I could choose anything in here. I could choose the 0.15. So if I chose the 0.1 comma 5, that means I can do 1 necklace and 5 bracelets. If I picked the point, as long as it's in the shaded, let's see, 210, I could do 2 necklaces and 10 bracelets. Okay, these are any of these points. So anything in the shaded region or on the line are solutions. So I know that was a little tricky. You just had to really think about what you're going to use in your word problem. And again, I'm sorry at the beginning, I should have called them the bracelets because that represents the number of bracelets. So that is all. I know that's a hefty lesson, but we will hopefully you guys will practice in class and be good from there.